This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will walk you through the solutions to exercise 2, questions 5 to 8, which are on variables and arrays. Question 5 is all about creating ranges and using them to compute some formulas. A vector t is to be created that ranges from 1 to 10 in steps of 1. We do this using the colon operator, starting at 1, going in steps of 1, and finishing at 10. We're also asked to create a variable theta that ranges from 0 to pi and contains 32 elements. The simplest method of achieving this is to use the linspace function. The range starts at 0, goes to pi, and contains 32 elements. Now that we have defined vectors t and theta, we're to use them to compute the following. X equals 2 times sine theta, y equals t minus 1 divided by t plus 1. If I was to hit enter here, I would get an error message because I'm trying to do a matrix division, which is not what I want. What I want is the element by element division of t. Therefore, we need to use the dot operator before the divide sign. Lastly, we enter z equals sine theta squared divided by theta squared. Again, I use a dot before the exponentiation sign to denote an element by element operation, and I also use a dot before the division sign. In question 6, we are asked to compute the discharge factor for the flow through an open channel of a parabolic cross-section. We are told that x is our variable, which is the ratio of the maximum water depth to breadth of the channel at the top of the water. We're told that x should be in a range of 0.45 to 0.9 in steps of 0.05. So we'll define that first using the colon operator. We need to define x first because we need it for our formula for the discharge factor. So MATLAB needs to know what x is before it uses it for the first time. We use the semicolon on the end of the line, which stops the elements of x printing and clogging up the command window. But you'll see that x is still defined in the workspace. Now we move on to define our discharge factor. This returns an error because I have missed out a dot operator somewhere in the equation. Using the up arrow to retrieve the function and looking at the function, I can see we need a dot operator after 1 divided by 4 times x. This is because we want an element by element multiplication, and now pressing enter, a row of discharge factors is returned as required. Question 7 is all about points on a circle, and we are asked to create a column vector for theta with several different values in it. We are told that the radius is 2. And then we're asked to compute x and y. X is r times cos theta, and y is r times sine theta. Now we have computed these, we need to check that x and y satisfy the equation of a circle. So we define a new variable so we don't overwrite our existing variable r, using a capital R, which equals the square root of x squared plus y squared. We need to remember to add the dot operator after both the x and y. We expect that capital R should return an answer of 2, the same as our original radius, which, once we press enter, we can see that it does. Question 8 is all about geometric series. We're told that the sum of a geometric series, 1 plus r squared, etc., approaches a limit of 1 over 1 minus r squared. We're told to calculate the limit and compare it with our summations. Starting by defining r as equal to 0.5, we'll define our limit as 1 over 1 minus r. We'll let that print so we can see its value, and now we calculate the first series, which is from 0 to 10. N will range from 0 in steps of 1 to 10. The first sum will be r raised to the power of n. You can see that it returns with all the elements in the series for 0 to 10. We need to sum all these elements together and compare them with our theoretical limit of 2. To do this, we can use the MATLAB built-in function sum. So typing sum, followed by the vector we wish to sum, sum1, hitting enter, we can see the result is 1.9990, which is obviously very close to our theoretical limit of 2. We now try the same with the series 0 to 50. Using the up arrow to return to the end definition, we alter it to go from 0 to 50. We then define sum2 and carry out the summation again. You can see that with 50 terms, we equal our theoretical limit, but you'll notice that MATLAB is only displaying 4 digits to the right of the decimal point. If we use the format long command, it forces MATLAB to display a higher level of precision. We then use the up arrow to run the command again. You will now see that this is not quite equal to 2. So, finally, we'll try computing the term with 1 to 100 terms. Hitting return, we can see that we've reached the theoretical limit of 2.
This production is copyright the University of Edinburgh.